Hello. In this video, we present the synthesis of lamotrigine, doubly labeled with nitrogen 15 and carbon 13, according to its retrosynthesis presented in the previous video. This labeled compound may be useful in researching the pharmacology and metabolism of this anti-epileptic drug. The synthesis of doubly labeled lamotrigine is based on constructing its triazine heterocycle through the reaction between doubly labeled aminoguanidine and benzoyl cyanide. The sources of carbon 13 and nitrogen 15 are urea, hydrazine, and cuprous cyanide, as we will see later on. Preparation of the doubly labeled substituted benzoyl cyanide. The regioselective metallation of the benzene ring of orthodichlorobenzene with N-butyllithium, followed by the reaction with methyl iodide, generates dichlorotoluene 3. The oxidative synergy between ozone and hydrogen peroxide, catalyzed by cobalt salts, transforms the methylbenzyl group in 3 into a carboxyl group in 4. The carboxyl group in 4, by reacting it with oxalyl chloride in the presence of catalytic amounts of dimethylformamide, is transformed into the benzoyl chloride 5. Addition-elimination reactions between the benzoyl chloride 5 and the doubly labeled cuprous cyanide 6 yield the doubly labeled benzoyl cyanide 7. Preparation of the doubly labeled aminoguanidine. The doubly labeled thiourea 8 is methylated with dimethyl sulfate to form the S-methyl-thiourea sulfate. Next, treatment with nitrogen 15 labeled hydrazine produces the doubly labeled aminoguanidine 12. Final steps in the synthesis of the doubly labeled lamotrigine. The reaction between the carbonyl group present in 7 and the amino group of the aminoguanidine 12 results in the hydrazone 13. The intramolecular addition of the amino group to the cyano group, followed by tautomerization of the imine formed as an intermediate, generates the doubly labeled drug. In summary, here are the main raw materials, along with their structural contribution. Thank you for your attention.